All right, my friends, we are here Friday night. There's very few things I'd rather do on a Friday night other than talk speaker talk with Anthony Grimani and Glenn Audioholics. How you guys doing?
Doing
We
well.
we are doing great, but I think you're lying. You may be talking about the truth in audio, but come on, there's better things to do on a Friday night. Well, maybe not. Don't know.
Well, I
Well,
don't know,
especially on
man.
East Coast time zone.
Yeah. Well, it's been a while since we've had you on the channel, and I just want to catch up. And I'm all hot on this digital EQ and active speaker stuff. And obviously, you guys have a whole product line about that. And I want to talk more about this topic simply because it's not talked about enough in our industry. And I think this is the future in speakers, much like EV is the future in cars in the next 3 or 4 years. I think we're seeing that emergence of technology happening here in loudspeakers, and you guys are at the pioneering end of it right now, doing it with all your speakers. So I wanted to continue that discussion that we've been having. I put together a playlist of all the live streams that we've done for you so far on Grimani Systems. So if anybody wants to go back and look at the older versions, we have all these different topics we've covered on your speakers before. But now you're going to get into more of the nitty gritty of digital equalization and sound power and all that other good stuff.
Right. Right. Absolutely. Yeah. What's interesting is I always hope we can talk about all the reasons why we do the things we do in our speakers in 1 hour, and it never happens. It's because there is so much. If you want to start to dive in and go and like flip through the pages and go, okay, well, what else is up with these guys? What's different with these guys? Why these guys? It takes a while. So apologies. I hope you find it interesting. I hope this makes your Friday evening, if you're watching live, or your other days, if you're not watching live, about as fun as it can be. I try to make this fun because I have a good time with it. So,
yep. You got your chocolate?
I have my chocolate. So tonight we'll be featuring this fine Hawaiian chocolate.
Let me zoom in on that. Hold on a second. Oh man, that looks nice.
So the good parts about it is there it is. This is a sea salt chocolate. It's got this very inspiring picture of a very cool Hawaiian lady surfing. I just find it very engaging, and I will be eating that now. And with all truth needs to be told, Glenn Aronsoff, who's joining us today, is actually who provided this piece of fuel. So thank you, Glenn. I appreciate it.
You're welcome.
Nice.
So
awesome, guys. Well,
it was worth coming back in the country to have that waiting for you, eh?
Yeah, it was great.
Got to have your chocolate to fuel these discussions.
Got to have my sound power is chocolate. So I have this slide about sound power back up because that ultimately is our goal. We're the reason my partner Manny and I started this company is to develop and launch speakers that had better sound power, which is a radiation bubble in the room that's more even. Speakers out there have varying radiation bubble with frequency. Sometimes they narrow up, they open up, they close, and whatever. And we're convinced that the right way to make a speaker so it sounds good in a number of rooms and sounds good at a number of seats is to have a much more even and full sound power. Now, to get there, there's a bunch of different things you have to do. I've talked about this at length. I am going to repeat because it is worth repeating. And I've noticed that politicians keep repeating the same thing, whether it's a truth or a lie, doesn't matter.
It becomes the truth if you keep repeating it.
They just keep repeating it. And this is our propaganda. Sound power really matters. You can worry about the cables. You can worry about the amplifiers and whether they're tubes or output MOSFETs or this. You can worry about all this stuff. But the biggest thing you're going to hear in difference between one speaker and another is in its sound power, its frequency response, and its net response in the room. So that really does matter to have sound power at all of the seats. It's as smooth as possible, which is that the direct sound from the speaker to you have a very even response, and also the off-axis sound going off from the direct sound to you, but that's the stuff that's hitting the back wall or the side walls or the ceiling floor, be also smooth without big accidents in it. So that's not just our opinion. A lot of folks have been claiming this. I have a book that I refer to back to 1952 by Harry Olson, old-time acoustician, who claimed that's the right way to design speakers. Dr. Floyd Toole, who we talk about a lot here, made his life task to prove this, to actually run enough measurements and listening tests on speakers to prove that, yeah, that is what matters. And so I agree with that. And we're going to talk about what it is today. We're going to talk about what we do with digital circuitry, with digital crossover and digital EQ in our speakers that should be done in all speakers to achieve this target of really even and smooth sound power. So as a reminder, when you're listening to a speaker in a room, and this is an example of listening to the center speaker as seen from above in a room with in this case, we're seeing 7 loudspeakers around us. There is a direct sound, and then there's a bounce off the right wall, and there's multiple bounces off all of the walls. That net set of red arrows you're seeing here, the net reflected sound plus the blue sound, is what's called essentially what you hear of the sound power, the net energy that's going in all directions and eventually passing your head at some point or another. So the reflections do dominate in listening rooms. You typically have 2 to 3 times more reflected sound energy than you have direct sound energy, and so it goes directly. If you believe that, and I'm not going to go through all of the texts and all the references. Just maybe I'll say, just believe me. That's what happens. If you believe that, if you take that propaganda, you'll realize that what matters the most is the quality of those sound reflections be as smooth as possible. So that's why we developed the CSA waveguide that's in our speakers, and that's why we resorted to using digital EQ and crossover to make the sound power as smooth as possible. And I'll explain that today, how we get there and what we have to do. So sound power, really important. Now, I'm going to go through this. I already talked about this in an earlier session. The sound power of a speaker is measured by international standards by putting the loudspeaker in a special measurement chamber and measuring 70 different points around the speaker. There's 2 ways to do it. The most typical way is you put the speaker on a little electronically controlled lazy Susan, if you want to think of it that way, a thing that spins the speaker in 10-degree increments. And you measure it on axis, and you turn it 10 degrees, you measure its response again, you turn it 10 degrees, you measure again. You go all the way around the speaker horizontally, then you put the speaker on its side, you measure again, which gives you the vertical charts. And some of you guys may have seen the work can I mention other people on the site? Can I mention Audio Science Review?
Sure.
Familiar with those guys?
We are, yes. Yeah.
So there's a bunch of guys in the Pacific Northwest of the U.S. who just out of the goodness of their heart take speakers in and do all of these measurements and these spinoramas and publish them. And out of that, you get if you publish it the standardized way that the Audio Engineering Society and other groups have kind of all agreed to, you'll get a set of charts that look like this, that represent the axial sound, so the sound from your speaker to your listening position, and then the listening window, which is an average of 5 points from 30, 15, 0, 15, 30, and plus and minus 10. That kind of represents the oval of what a speaker is looking at for an audience. That's called a listening window. In this chart, it's the green. And then you actually represent the sound that's hitting the walls and the ceiling and floor. That's called the early reflection. So it's a slice of sound kind of in this donut around you, and that's represented in yellow. And then you measure all the way around the speaker and you average all that together. That's the sound power. In this case of the speaker, that's the blue one. This is a representation of our biggest speaker called the alpha. And this is something that would normally be known as, hey, that's going to be pretty good, and as in the progression is really smooth. Now, there's another speaker we make, the tau. Different topology, but there again, you see that the progression from axial response to listening window to the reflected window to the sound power is an even transition. Of course, the sound power is lower in our speakers. They're not spherical; they're hemispherical, which means that the sound power is typically going to be 5 or 6 dB quieter than the direct sound. But it's a smooth transition. These are an example of the individual curves that will make up the sound power. So this is one of our smaller speakers, the Rixos-S, showing the horizontal curves individually. And this can be a bit of a head twister to measure out, but there's things that happen here in the crossover that are smooth here and not so smooth in other speakers that justify why we're doing a digital crossover, which is the topic here today. By the way, here's some responses on other people's speakers. They'll go unnamed, other things that you can see out there. Here are some charts that show, in this case, actually, this is not a spinorama, but 0, 10, 20, and 30 degree measurement. And you'll see there's some errors over here that come from the way the crossover is done. Here's a spinorama result on another speaker. And you can see that these are diverging. They're not even transitions. Things are up and down. The directivity index goes up and then back down and then back up. That's a speaker that's going to be very sensitive to the room it's in. It's going to sound one way in one room, then it's going to sound a different way in a different room.
So it's less predictable in a room.
You could end up with decent sound with a speaker, but the chance of that is reduced compared to a speaker that's got a much smoother sound power response. Here's another speaker, and here's yet another speaker. These are just other people's speakers that'll go unnamed, and those are more typical curves you'll see out there from manufacturers.
So Anthony, another point to make is when you have a speaker that doesn't have predictable curves off axis and the power response and all that, is it becomes less effective to EQ a speaker like that, right?
Yeah, and then we're gonna talk about that plenty. So let's say you use this speaker. All right, let's look at this one that has a reasonable axial and listening window response. There's a little dip over here at 4.5K. I doubt that anybody would hear that. It goes rising up a little bit here, straight on axis. The listening window is pretty good. So the stuff that's going directly from the speaker to you is pretty good. But then the stuff that's bouncing around the room goes in a decline here from the low frequency, and then it levels up and then comes back down. So the room return is going to be this red curve, and the direct sound generally is going to be this white curve. So what does that sound like? It's funny. I was just on the phone with somebody for quite a while about equalization he was trying to do, and he was noticing this on this kind of material, that on that kind of material. What's interesting, and in what you bring up, is this, Gene, impulsive sounds, things that have a short duration. So I don't know, I'm going to always bring up cowbells or, things that are kind of dynamic
and
transient.
Yeah.
Transient, which again is a term us audio geeks use to just talk about something that's a thwack. Your ear brain mainly pays attention to its direct character. It's short-lived. That's what you're paying attention to. And then something that's longer-lived, like a person going hello, or an orchestra playing a long note, or a rock band going wow, that lives a long time and sits in the room a long time. And so you're going to hear this. So if you listen to the speaker in certain rooms, especially if the rooms have got a fair amount of liveness, and you didn't equalize it, the speaker could actually sound a little on the dull side, even though its axial response is good. Until transient sounds come along, then it's going to sound fine. If you were to equalize that either if you measure the speaker, if you actually were to put a regular microphone with an omnidirectional character and measure in steady state, you're going to be largely measuring this response. You're going to see that it's depressed in the mid-range, comes back up, and you may be tempted to equalize that up to make it flatter. And if you do that, the transients are going to rip your head off. They're going to be like, oh, ah, oof. So that's what you mentioned. When you have these differences, these vast differences between the direct sound or listening window and the sound power, for one, the speaker is much more room to room dependent because the sound power and the reflection on each room is going to be a little different and the sound is going to change. For two, if you try to equalize it, you got to be really careful because you may end up equalizing out the sound power and making the direct field terrible or vice versa. And it's a conundrum.
So I would imagine in a speaker that doesn't have a good even sound power like you were showing with your active ones, you'd probably be putting more sidewall absorption in those cases to kind of drown that out, right?
So what do you do with this? So yeah, it's interesting. I'll tell you a quick story. For a long time, the big mains loudspeakers, as they were known in recording studios, had horrible response, especially off axis. They were very directional, big horns, lots of big woofers, and their off axis response sucked. And the only way to make those things sound good was to put thick amounts of absorption on the sidewall to get rid of that reflection. So now you're listening to the anechoic response of a speaker, which is not either very pleasant and doesn't match what you hear at home. But on a speaker like this, I would be inclined to put more absorption in the room so you hear more of the direct sound and less of the erroneous sound power. Problem is, as you put more and more absorption, other things start to fall apart, which is a sense of immersion. The speakers tend to sound very spotty, where you hear, for you guys, the left here and the center there and the right there and the side excuse me, the side right is like, you know, you hear a speaker rather than have an immersive integration of all the speakers. So
Yeah.
what's better overall, you know, if you're starting with good ingredients, your cooking is going to be better. If you start with better cocoa, your chocolate's going to be better.
Sure.
Mm.
You had to go and throw a chocolate
It
plug.
always
There
comes
you
back
go.
to the chocolate.
I had to throw that in there. So, generally speaking, if you can get your hands on a spinorama response of the speaker and see the axial response, the listening window response, the early reflection response, and the sound power, and you can see this, you can start picking speakers in which those things are smoother and better correlated to each other, because it just makes your life easier. And you can actually build rooms with less treatment, less absorption. Diffusion is a slightly different story, but a little less absorption, and get a really better tie-in between the speakers. It sounds cleaner. You don't ever want to dump out all the absorption. You don't want full reflection in the room, but it's not as simple as the directivity index of the speaker or the direct to reflected sound. It's also how the sound power ties in there.
Mm-hmm.
So I'm just showing you examples of several things out there, just to kind of get a reference of how it works. These are just various other speakers. You look at this one, the sound power goes far down over here compared to the axial. The axial is not real pretty. This speaker could definitely benefit from having the mid-range turned up, this bump over here turned down overall, because it'll smooth everything out. But
I think I know what speaker that is just by that 2 kilohertz dip.
Yeah, possibly.
British.
So, interestingly enough, this is the estimated in-room response of this speaker. So I was saying earlier that if you average these things in the right way and you go, well, if I put the speaker in the room, other than variations in the bass that are a completely different story than the sound power, those are about standing waves, let's not talk about those, but above 100 hertz, that is what the speaker is going to measure like and probably going to sound like. As in around 2.5 kilohertz, there'll be a dip in this mid-range, and it'll make instrumental music, it'll make orchestra sound really smooth, violins will be, the harshness of violins will be attenuated. Some people may like the sound. But it's wrong. It's not the truth.
You know, Anthony, I wonder, is it almost like a head-related transfer function? Because I see companies deliberately doing this. They put a notch at around 2K on their speaker. Is it to give a more presence of airiness to the sound?
No. So it could be one of 1,000 reasons, and I've witnessed some of this in the past. So some of it would be they intentionally know that by doing that, the speaker sounds smoother. So when you're comparing 2 or 3 different speakers, that one's going to sound a little more gentle. Problem is, when you're using it in a home theater, the dialogue's going to be unintelligible because the level of dialogue is a full 6 dB down from the level of or the intelligibility of dialogue. The place where you actually understand what people are saying is going to be 6 dB down from everything else, and it's going to be like, huh? And then you're going to be tempted to turn on the subtitles, which is not the way you should watch a movie. So one thing is that it's sometimes an intentional thing that manufacturers do to make the speaker sound smoother. 1, 2, maybe the designer of that speaker was listening in a room that actually had an enhanced character in this region, and that's what it took to make that speaker sound good in that room, and that person didn't do any measurements. Maybe the mid-range driver on the speaker was not so good above 1 kilohertz. It went into breakup. And so rather than let it go, they actually just put a low-pass filter a little bit lower, and the tweeter couldn't be moved down because it just couldn't take the power. And they went, fine, let's just do it. There's a lot of reasons why these things happen. I was, interestingly enough, right in front of a speaker like that on a calibration I was doing last week, and the customer was complaining. Yeah, it's really hard to understand the dialogue on this really expensive system I bought. It's like, well, yeah, let me tune this thing out. And they were like, oh, much better. So I'm not going to go over this. Let's jump with that introduction that took half of our time. Let's talk about what it is we do at Grimani Systems that we hope will be kind of market leading. We're not the only people doing this, by the way. But we're one of the few people, especially in the residential space, doing all of the things we do here. So this picture shows our alpha speaker, our biggest speaker, our 3-way flamethrower. The thing plays 130 dB, will light up a 200-seat movie theater with really loud sound. But here's what we do with this kind of speaker. So in the best of all worlds, we would take the digital output of a surround decoder, which I'm mentioning two brands over here that provide digital output, Storm and Trinout, but I think those are not the only ones. There's a few other manufacturers now that have either AES EBU output or what's called AES 67, kind of Dante-like output. Doesn't really matter. You would take the digital output of your speaker, you would plug it into the network switch that's part of the digital distribution of audio over IP, and you feed that into our speaker. So what's coming in is actually a digital signal directly off the source, whether it's a stream source or a disk source or something off a video server. And that hits the input of our speaker. This red outline kind of represents the overall block of the speaker. First thing is the AES 67 signal, if that's what you're feeding, is received, processed. The speaker also has an analog in case you want to feed it analog instead of this digital audio over IP. Then inside the actual signal processing block, there's equalization for room correction, for making the speaker sound good in the room, for tuning the speaker to the room, for tailoring the speaker to the acoustical character of the room. Then there's a time alignment function to set the time of the speaker relative to the other speakers in the room and relative to the video to be right. Then there's a three-way crossover that separates the highs from the mids to the lows, and the crossover is done with really steep slopes, which is a cool thing you can do with in the digital domain. So we're using 48 dB per octave slopes. So where the tweeter goes down to and hands off to the mid-ranges, there's very little overlap. Mm-hmm. And by not having an overlap, you don't end up with a long line source of speakers that create comb filters. In the analog domain, you could do that steep of a filter if you were very tricky about it, but in a passive crossover, you can typically get to 24 dB per octave before you have just way too many parts and you're throwing out too much power out of the speaker. So doing that in the digital domain gives you a really infinite, really sharp slopes. That means that where the woofer is done, it doesn't continue. The tweeter takes over, the mid-ranges, sorry, take over, and then where they're done, the tweeter takes over with a really a very clear delineation. Then
plus
we actually
your bandwidth limiting your amps too before the amplification happens.
Correct. The amplifiers are then only handling the high frequency, the mid frequency, and the low frequency, and not anything more. We also have delay for each individual component to time align the speakers so that the plane of the mid-range and the plane of the woofer and the plane of the tweeters are all realigned so that the sound power is even. We can also do all-pass networking so that any phase rotations that happen either electroacoustically or because of the filter slopes or because of the shape of the cabinet, those can all be compensated. Then we implement protection so that even if you crank the speaker way above its peak limiting peak capability, there's a limiter that controls it. And we sometimes implement that protection at lower levels in case the customer says, well, I want to make sure I don't blow out my ears with these big speakers. So we actually turn the limiter levels down. And all of that is addressed through IP. So in a completely modern speaker, the signal's coming in through a Cat5 cable using audio over IP. All of these functions in the digital crossover and processor are implemented with 40-bit precision, so really high quality. And it's all controlled, monitored, tuned by connecting a computer to the thing. And the computer is typically through Wi-Fi. You can connect it through a cable.
So is the amp rack mounted and then the speaker just gets a speaker level connection? 3 speaker level connections in this case?
So the alpha speaker that you see here, all of that's happening in the bottom section. I hope that's resolving over your screens.
Let me zoom in on it.
Yeah.
So the amp is built into the actual speaker.
Right. So in this one, everything I just described here, which is all of these inputs, all this crossover, this delay protection, IP addressing, and the high frequency, mid frequency, and low frequency amp that drive the speakers are all built right into this lower part of the speaker. It's an internally amplified. All the electronics are in that speaker. That speaker is designed to be mounted on a wall, not inside a wall, but on a wall, and it's all done internally. On some of our speakers that are designed to be in wall, like where you actually cut a hole in the wall and put the speaker in there, you're actually not allowed to put these amplifiers that spit out to 150, 200, 300 volts. You're not allowed to put those in there because it's high voltage. And so the amplifier, this section is split off as a block outside the speaker. It's in a rack, or it's in front of the speaker, above the speaker, wherever you want to mount it. And then 3 sets of wires go drive the tweeter, mid-range, and woofer on our speakers that are made for in-wall.
Gotcha.
Typically, our in-wall speakers are all in this line series called Rixos, which I talked about 2 sessions ago. That's our line. That in Greek means shallow, and we needed to make them shallow so that they can fit inside a wall.
So if somebody's pre-wiring a new home theater right now and they wanted to implement the speaker up as their front 3 LCRs, they would be pre-wiring Cat 6 to those locations?
So if it is this speaker, if it's this one or any of the other ones in our line that are internally powered, you would be running Cat 6 to the speaker from a switch somewhere. And we'll talk later about what it takes in that switch to make it work. And then, of course, you need power. You need 120 or 220, 240 volts, whatever it is that is in your region. So let's talk about this. So if you are, this connection thing, if you are planning to run AES 67, Dante being one subset of that, there's a few different initiatives. I don't know how to. There's a few different technology licensors that have implemented AES 66 audio over IP. Dante being one of them. There's another one. Oh my God, I'm forgetting the name. It's a Ravenna. There's a few other ones out there. And if you want to do that, just you need to think about how you're doing your switching in the IP. There's people who say it's better to just run a completely separate set of switches of network switches for the Dante. There's people who say no, you can run all of this on the same network. You may need to be careful about what addressing you apply. You may want to do sort of virtual networks, virtual private networks, or virtual switches, virtual addresses. I'm not going to go in there, but theoretically, you should be able to take the multi-channel AES 67 output of one of those surround decoders, go with a single Cat 5 or Cat 6 cable right into a network switch, and then out of that network switch right into the speaker, and everything should work fine. I would say it's a little bit more complicated than that.
Mm-hmm.
So a little more about what goes on inside here and why we do it. The reason to do digital crossover and EQ is it's more efficient. You're not throwing away a lot of power in the crossover. So let's talk about this. In a traditional loudspeaker, you've got a signal coming from the amp. It goes through a bunch of circuitry that separates the signal for the highs, the mids, and the lows. But the way it does that is it filters out the signal it doesn't want. Filtering it out means throwing away power. So at minimum, you're going to lose about 3 dB of efficiency from your amp. Sometimes you lose 6 or 7 or 8 dB of efficiency. 3 dB is twice the power. So if you had a 200-watt amp driving a crossover, you usually end up with only 100 watts worth of signal to drive your tweeter, mid-range, and woofer. Sometimes it's more than that. 200 watts could become 50 watts on the back end, depending on how the designer built the crossover. It's just not efficient. With an active level crossover, you're not throwing away any power from the amp. The amp's connected directly to the tweeter, directly to the mid-range, directly to the woofer. In the case of an internally amplified speaker with a wire that's only this long, which is really cool. It is more precise. There's only so much you can do out of passive crossovers to make the response be completely smooth. With an active crossover, I'm going to say it's almost a cheat. It's almost too easy. I shouldn't say it's that easy, but designers of passive crossovers, which I designed many over the years, have to deal with this very difficult process of using the right components within the limits of the tolerances of this thing and that thing and the power, and it's a puzzle. In the active domain, it's a lot less of a puzzle, but instead you just take the extra time you had to produce a more precise crossover, which leads to a more precise frequency response and more precise sound power.
Well, it's also repeatable. You don't have the tolerance variances between crossover to crossover.
Right. So the repeatability is an interesting thing. In modern drivers, modern tweeters, mid-ranges, and woofers, if you measure about 100 of those, for most of the decent vendors, you're going to find a high degree of repeatability, the drivers themselves, which is not what you would expect. That you would think that's the part that's got the most slop, but they've gotten really, really, really good. The things we see over here coming in incoming QC, you get a whole batch of 200 of these things, and they all measure exactly the same. But the passive crossovers, the resistors, capacitors, and coils you're getting, they all have tolerances in them, and they drift over time. They drift with temperature. They drift. So it's very hard with passive crossovers to have that repeatability that Glenn brought over. In a digital crossover and an active crossover first, if it was analog, and then in digital, the repeatability is amazing. The flexibility is amazing. So in the end, you end up with better sound quality. So let's talk about this thing of sound quality. And I don't really have a chart that explains what I'm going to show. So I'll use, being Italian, I'll use my hands. Okay. So let's go back to the sound power thing, which is why I started there. Ideally, you want a speaker that has really smooth axial response and a very smooth listening window response and a very smooth reflected area response and a very smooth sound power. And in order to get there, there's a bunch of things you need to do. One of them is you need to make sure that the directivity of the drivers never gets so high that it's beaming, which is that, you need to select your woofers and your mid-ranges and your tweeters so that they are played up to a certain frequency and then they're crossed over before they start to beam. But in the crossover region, you need to make sure that it's steep enough and time aligned and phase aligned so that there aren't peaks or dips in the response vertically or horizontally that come from some time domain errors. And those things are very hard to control in the passive analog mode. Let's see, Glenn is saying my audio is feeding back. Is it, I see, Glenn. All right, cool. Sorry, I'm seeing all these notes show up while I'm talking. It's distracting me. What can I say? I'm going to turn my speaker down. Can you hear me okay, guys?
Yeah, I just muted our mics. That way we wouldn't hear feedback coming into yours. But yeah.
Or you mean echo or feedback that's going, woo?
I was hearing echo.
Okay.
It was from Glenn's mic.
Okay, cool. So continuing with my little dance of the hands, to have a more smooth sound power, you don't want the woofer, after it's crossed over to the mid-range, to continue to stay in the picture where it's starting to beam, for one, and then creating interferences between the woofer and the mid-range. Those interferences vertically will cause errors in the vertical domain, or if a speaker is laid down horizontally, it'll cause errors in the other.
Anthony,
what I mean by beam,
there you go.
A decent driver is going to radiate out into the room with a pretty wide bubble. Let's just say from the direct sound going to you out to about 60 or 70 degrees. So the bubble's nice and even. Beaming is another word for hot. If you take a 12-inch woofer and you play it at 5 kilohertz, which a lot of 12-inch woofers can play up that high, it's going to radiate a beam towards you because the woofer is this big, but the wavelength is only this big. So it creates this focus towards you, because it's almost like it's creating the simplest way I can explain it without getting into the physics of it is it acts as a parabolic dish for its own signal. It focuses it forward. So that's what I mean by beaming. And once it's hotspotting towards you, the person to your side is not hearing the same sound and the wall's not getting the same sound. So now you have these errors in the reflected pattern, errors in the sound power that are hard to recover. And I'm glad Gene brought up that question about equalizing and listening one way or the other, because that's what it comes down to.
Yep.
So you want to take a woofer, let's see, beaming is when the higher frequencies are very directional, not good dispersion. You are correct. Thank you. Thank you, Jonathan. So what you want to do in a properly implemented crossover in a speaker is you want to take the woofer up to where it may start to beam and where it may start to misbehave in the frequency response. Then you want to cut it off and you want to hand off to the mid-range. And if the cutoff is gentle, because you're using passive components or you don't have the flexibility, you will end up with some problems. And in the digital domain, with a good processor, you can make that cutoff almost infinite at 48 dB per octave, which means it's like a brick wall. And then the mid-range, same thing. You can bring the mid-range in very, very steep, align the time alignment of all of that just perfectly to where the mid-range is not overlapping with the woofer. If they overlap, now you've got a mid-range and a woofer that are trying to play together, and they're going to create a hotspot this way. And you don't want that. Same thing in the mid-range to the tweeter, or same thing in a two-way speaker where the woofer mid-range device hands off to the tweeter. The sharper the crossover, the less there will be an overlap, and the less there will be beaming problems. And those hotspotting and beaming problems all translate to sound power issues, which translate to sound quality that's a little compromised, and variations from room to room in sound quality. Speaking of variations, one of the best ways I love to show this to AV dealers when I'm working with them is when they actually put a bunch of in-ceiling speakers all the way around a house, and it's the same speaker, same whatever, 6.5-inch two-way. I love playing some music when they don't understand this thing and I'm talking about. I love to play some music and say, let's walk around the rooms. And in one room, you got one acoustical character. The next room, there's a different acoustical character. The third room, it's a different character. It's the same speaker playing the same sound. And you can hear how drastically the sound of the speaker changes from room to room, because the sound power is influenced by the room around it. And the smoother the sound power, the less there is a difference. So that's one of the reasons we want to implement this stuff in the digital domain. Now, at that crossover region, there will be errors in the time domain where the wavefront coming out of the mid-range doesn't quite match the time of the tweeter. So where they may be a little bit out of phase due to lots of things, not only placement of the devices on the baffle. I'm showing it this way so it's easier. Not just placement, but also the electroacoustic phase response of the devices. Even though they may be on the same plane, they're behaving differently in the phase domain. Well, the cool thing with the digital crossover is you can compensate that. You can actually bring in different filter curves, different filter characters. There's several filter types. Butterworth, Linkwitz are the two most common ones, but there's 4 or 5 other choices you can do that change the phase response around the crossover. And you can rotate in if you have the right devices. You can actually bring an all-pass network that doesn't change the amplitude domain, but just does phase rotations to compensate for those errors. You can also implement a time delay. So if really the issue is a positional alignment issue, you can delay that device, if it's the tweeter, until the mid-range can catch up and everything is fine. You can't do that in the analog domain. Mm-hmm. You can't do that. You can certainly not do that in a passive crossover, and it's really hard to do in an analog active crossover. When you resort to digital crossovers, you can do all that quite handily. It doesn't take that long. It's repeatable. It works super well, and you can you measure in the chamber. You can listen to it. You can actually do some trial and error quickly. Turn the thing on and off. Like let's say you say, well, an all-pass network is improving the response, both the direct response and the sound power response. Let's hear if I can actually hear the difference. If you had an analog crossover, you'd have to build all these switches and all these different boards. With a digital domain, you just go to the virtual switch on your computer and go click, and you go, can I hear that? And you can usually. So
do you, question real quick for you, do you set all the crossover points at the factory, or do you actually customize that based on how the speaker's playing in the room? Do you change those things? Or
so that's a good question. So in our speakers, there's actually 2 sets of a digital signal processing EQ stage, and I kind of oversimplified this diagram. The first one is actually the one for room correction. There's a bunch of bands of filters that you can access to correct for whatever the room is doing to the speaker. Too much bass, too little bass, too much mid, whatever it is. That's one set of bands. Then there's another set of bands that are the ones that are locked at the factory, that are the ones that produce these spinoramas I showed you earlier that are really smooth and make the speaker sound good and make the speaker less room dependent. So the answer is the crossover, the character of the speaker is all set at the factory to make it a good speaker. But we know that you take a good speaker, you put it in any room, the room's going to change the sound of that speaker the same way as these hands change the sound of my mouth. And there's a separate set of filter curves, usually about 6, 8, 10, depending on the model, that you use to adjust the speaker to the room. And that is in order to custom tailor the speaker to the room, or in some cases to the listener. So Occasionally I work with listeners, it's the minority, where all of us on this session today would say that sounds good, and then that person goes, it's just too much, it's too brilliant, too many highs, I don't like it that much. And you go, really? It sounds right. It's like, no, just turn down the highs, turn down the treble. Then you turn them down. You can just tune it to what they like. Doesn't happen that often. So this is a screen dump of the amplifier that drives, in this case, a Rixos-S. And I'll just kind of comment from left to right. How are we doing on time? All right. From left to right, there's the input stage that has a meter that you can see how far you're hitting into the input headroom. Then this over here is actually the gain structure of the amplifier, which is just setting the overall gain of the amp. This over here, this first stage, is the room EQ and compensation stage. For this particular speaker, whatever I was doing, wherever I was, that's what the speaker needed to make it measure and sound good in this room. Not a lot. One little dip here around 100 hertz, another dip at whatever that frequency was, which hopefully the next slide shows it. And then this stage over here is the high pass and low pass and EQ to make the tweeter and the woofer sound good, work well, and make a good speaker. This is the output stage that just shows us how many, what the voltage is. If we're putting a limiter, it'll actually show a dB of gain reduction if there is a limiter. So that's a really, really great dashboard to be able to look into the speaker. Before this, in the early days, years ago, if I'd be designing or working on a speaker, I'd actually have test probes and oscilloscopes and voltmeters all hooked up everywhere so I could monitor this stuff. Now I just open my laptop and boom, I can see all this in all of our speakers. So if you take this chart and you drill into this portion right here, this is, Gene, exactly what you had asked. If you take this chart and you look at the low frequency on this is a Rixos-S. This happens to be the low frequency response fed to the woofer of our Rixos-S. This is a small 6.5-inch woofer with a 1-inch high sensitivity tweeter. You can see here that the low pass is at 1.4 kilohertz with a 48 dB Linkwitz-Riley character. And then we've got these 3 bands of EQ and filter to drive the woofer to what it needs. And this is the response of the tweeter on that speaker. That's what it takes to make that tweeter work well. And that woofer and that tweeter together, when you splice them together, you get this really smooth response. There's probably somebody that's going to go, how do you get a smooth response out of a tweeter that's had this severe attenuation here? So look at this. We actually have to turn the low frequency of our tweeter down about 15 dB compared to the highs. How do you get that? Well, because we put this tweeter in a waveguide, and the waveguide actually acts to emphasize its sensitivity at low frequency, we can actually turn the low end of the tweeter down so that it doesn't work as hard and can play a lot louder.
You get more dynamic range that way.
Way more dynamic range out of the thing. And then this is the input EQ. That was, I'll go back 2 steps here. That is this particular curve here for this room. I forget what project this was. I'm sorry. Something.
So just to interject real quick, you're doing all this manually. You're not using DRAC or you're not using a room correction system. This is your proprietary recipe, right?
So it's not that proprietary. We put up 4 microphones in the room. We plug them into a little switcher called a multiplexer, either done in the analog domain or digital domain. We measure it, we look at it, and then we go and adjust these bands of EQ until the response follows a known target curve. So it is the thing we're doing that's different to Dirac or Trinov or other things is after we've noticed the error, we don't tell a machine to compute the correction. We just do it ourselves. How long does it take to grab a band, go blink, blink, done? The measurement takes just as long as an auto EQ. You got to plant the microphones, move them around, do all this stuff. That takes just as long. It's just a correction. Instead of having a machine run the calculation on the filters, we just do it manually. And it turns out that because we start, this is going back to your question, Gene, because we start with speakers that have a really even sound power, in which the Taylor is kind of pre-thought of, the response of the speaker is pre-thought of as working well in rooms. Here's a typical amount of correction I find myself having to do with these speakers, little things, not very much. That doesn't take that long. This was that particular condition In red was the response of that speaker before EQ, in green after EQ. So not very big differences, but there was a hump over here around 150 hertz I had to turn down. There was a little bump in here around 3 kilohertz I turned down, and there it goes. That's it. So
was that a house curve that you were showing? Because you had the elevated bass about a good 10 or 15 dB.
That is what I call the target curve that was appropriate for this type of room. And in that, we're following very much the work of what the fine guys at Harman have done. All of the measurements I did at THX for 10 years before that sort of confirmed that that's what, when you get to something that everybody goes, that sounds good, you measure it, this is usually what we're going to see, is a little bit of elevated bass here, about 5 dB over the mid-range, a gentle downward slope, and then somewhere between 8 and 10 kilohertz, you're going to see a natural fall off. That doesn't mean the tweeter's falling off. It just means that the net air absorption of the room is letting less sound get to the microphone. The tweeter's still feeding a direct sound to you that's flat response, but the net sound power is necessarily going to be attenuated. If you made this flat, if you made this into a flat line, the speaker would sound harsh and bright, have no warmth. Don't do it.
Yep.
So one of the cool things that you can do once you have a digital crossover, like in our speakers, if that is controlled through IP, not all digital crossovers are IP controlled. A lot of them are USB controlled or some other very proprietary connection. But if it is IP controlled, like on all of our speakers, you can, from anywhere in the house or the church or the concert hall, you can control the speaker. But also, if you're a dealer, when you go back to your office, if you can dial into that house, which most dealers have a connection through either VPN or some other means to get into the residence or into the project, so that they can control network updates, whatever they have to do. Dealers are always dialing in to be able to correct and update things in the residence or the commercial space. Once you do that, you can also go talk to the speakers. And so at any given time, I can, from my office, go in to any of the clients we do and check the status. I can go, how's everybody doing? How's your temperature? Are you all on? Are you overloading? Is everything cool? Our speakers also, the amplifiers are measuring the impedance of the drive unit. So I can check, hey, is the tweeter still 8 ohm? Is the woofer pair still 6.5 ohms, whatever they're supposed to be? If one of the woofers went open circuit on any one of the rooms because somebody overdrove them and the thing blew up, I would know it right away. I can see that, hey, instead of being 8 ohms, it's infinite ohms. But wait, there's more. The systems we deploy out there actually run an auto diagnostic on their own. Every 15 minutes, they're going through and checking all these parameters. And if any of those parameters that relate to health of the speaker are found to be outside of spec, we get pinged with an email, and an email usually goes to the dealer also to say, hey, something's wrong. So this error reporting means that we often find out if there's a problem in the client's installation before the client finds out. Guess what the most common error is we find?
Power.
Hello, I am the left speaker at the McCormick residence and I have no power right now. Okay, so you call somebody and you find out that somebody pulled the power out of the wall to plug in the vacuum cleaner and forgot to plug the speaker back in. Okay, well, that's fixable. So once we detect an error, when something's wrong, we can dial in and we can run through a bunch of tests, including acoustical tests. If we're allowed to plant a microphone in the room, usually hidden somewhere in the ceiling, in the back wall, not an ideal place, but a place that we've benchmarked after we've calibrated the room. So we know, we calibrate the room with the target curve I showed you before, where the microphones are at the right place. And then we hide a microphone somewhere else and we measure what we get at that hidden microphone from the conditions where everything was working right. We can actually run a test sweep and go, how's the speaker doing? Is it distorting? Is it missing a driver? Whatever. We can do all these diagnostics, kind of like grabbing the calibration and test kit, going in the car, driving 100 miles and measuring. We can just do it right here from the comfort of wherever we are. And I've done this from my in-laws in South America on a system in Belgium to see what's going on. So I know how it's done. I'm still blown away when I'm sitting there and I'm across the world and I can detect the problem that then the dealer can go figure out what got disconnected. I think that's really
Are you ever able to fix it there without having to have someone go to the house and fix it? Is it something that could be reset in the processor or?
So here's a few things that happen. It depends on what the failure is. If somebody pulled the power out of the speaker, I can't do it from
Right.
Argentina if it's over in Belgium. Sorry. No matter how hard I try and I think about it. And no, if it is a condition where a surround decoder, this can happen. I'm sure Gene and I'm sure you guys that are listening have seen this where somehow the surround decoder has just gone, blah, 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 blah. It just needs a power cycle. If we have access to something that can reboot the surround decoder, which is, most common one is a brand out there called Wattbox, but there's many of them. I really like Taurus Power is a really high quality version. You can do a power reset, watch the whole thing come back up, and you're done without bothering anybody. That's cool. So it all depends on what the failure mode is. If it was because something needed a firmware update, you can do that by remote. It depends on what's there. If it turns out that the failure comes from the fact that somebody, I don't know, overdrove something or flipped the speaker sideways because they were having too big of a party, there's nothing I can do from sitting in a room far away.
Yeah.
So that's kind of a quick view of why it is we've decided to do this digital crossover and EQ and room correction and monitoring. I know there's people who go, well, digital is bad. I can always hear digital. I can tell it. It's like, well, we've done a lot of listening tests. There's been a lot of listening tests over the last 20 years, and a well-implemented digital system is going to let an analog signal through no trouble at all. We've played really high-end turntables with really expensive preamplifiers into our speakers, and people think they sound fantastic. So it's the kind of the oldest school source into the newest school playback, all digital, and people are enchanted. I've played a Studer tape machine running 15 IPS with a Dolby SR noise reduction into our speakers, and it sounds glorious. So that whole business of digital versus analog, I wish we just wouldn't talk about it anymore.
And especially because in a home theater environment, all your sources are pretty much digital anyway.
Yeah.
So you're keeping the digital path all the way to the amplifier.
Yeah.
Because if you get a Storm or you get a Trin-off processor, you're not doing an analog to digital conversion. You're taking that AES-17 output, you're going right into your DSP, you're doing all your filtering and your crossovers there, and then you're converting it to analog and amplifying it just like you would normally.
Right. So you asked about, the hookup. This is as simple as the hookup could be. Just cat cable going to each one of the speakers. Speakers are powered. The setup can be really easy. Less wiring means less trouble. Connecting category cable, most people know how to wire that and not do polarity inversions or miss a leg of this or that. So it's just that simplicity of installation and hookup just makes life easier all the way around. So I'm not going to talk about that. So there it is. That's what I wanted to cover in the conversation about the benefits of active crossovers, especially if you're doing digital ones. I didn't get too far into the business of room correction. I think you guys know that you can apply a bunch of bands of either parametric EQ, high pass, low pass, shelving filters and things like that to tune a speaker to a room. We could spend an entire 3 hours talking about how you do that. But the point is, in our speakers, that's all included. So it's when you buy one of our speakers, all those functions are already in there. You don't have to add an external equalizer processor. It's all internally included in the amplification and preamplification sections.
I think would be a good video topic aside from the series we're doing on your products is just talk about room curves or house curves or how to set an appropriate house curve based on a listener. Because you showed the Harman one where you have a 5 dB bump into bass and a gradual taper off in treble. But then you have to have a Donimus curve. Don Dunn likes his bass 20 dB hot. So and you have to have different presets for that. And people do have different preferences. I like bass a little bit hot as well, but Don likes it like crazy hot.
Yeah.
But I think there's there's a lot of value to that, especially now because like Odyssey has an update with their Odyssey X where you can go and dial in a house curve after calibration. How do we know how to set a house curve? You know, maybe you can kind of give us an education on how to do that to get people at least to get in the ballpark of good sound, and then they can tailor it from there.
I'm gonna give you 2 or 3 quick notes, and then let's talk about it. This is really interesting. So there is no house curve, because every room and every speaker in every room is going to interact differently with the room, to where what's entering your ears, the net sound power of what's entering into your ears, is going to sound different. And what ends up sounding, let's just say you could dial enough buttons until you go, yep, that sounds perfect, and 10 people listening go, that sounds perfect. You measure it, and you're going to find a slightly different tilt from one room to the other. That generalized curve is one that's a good target most of the time, but I've found sometimes that's too dull, and sometimes it's a little too bright. It's a good midpoint, but it's not perfect, because it does depend on the sound power of the speaker and the reverberant character of the room. So if a room has a reverb curve, for example, like the one I was in, that same one that had the speaker with the mid-range hole, that has a bump in the mid-range to where the reverb is longer in the mid-range than at the low frequency, and then rises up and then falls off at the high frequency, which is not uncommon in big reverberant spaces. It's funny, Matthew Poe sent me a bunch of reverb measurements on big rooms. Like, wow, look at this. This is really weird. It's like, no, it's pretty common in these big rooms. The way the speaker is going to interact with that and how the microphone is going to measure it is all really different from space to space. So my little trick in the end, and I'll gladly talk about this, is I dial up a house curve, I play pink noise on the speaker, and then I grab these really high-end earbuds I have from Etymotic that were made for medical measurements. Stick them in my ear, listen in pink noise in the ear, listen to the speakers, listen to the ear, and you're done when those two sound about the same. And you'd be surprised how often they don't sound quite the same, even though you're drawing the perfect smooth house curve that the Harman guys recommend.
You're talking about full bandwidth pink noise?
Full bandwidth pink noise. And it's really interesting. And then when you do this test, you do the comparison, and in the end, you dial it to where it sounds good in the comparison. You put all that aside and you play your 20 favorite music cuts. They sound right. And they sound right to me, and they sound right to her, and they sound right to him, the other people in the room. And ultimately, that's where the proof is hey, does the music come out right? Do the films come out right? Is the dialogue intelligibility right? All the transients, do they sound right? And that's usually where you've gotten to that point. So it is that fact is frustrating, because I wish I could just show up, put up the mics, be on the phone the whole time, do something else, just get to a point where the computer says, oh yeah, this is the curve you're going for, and have 100% assurance that it's going to be right. It's not. And that's the problem I have with auto EQ in general, is it assumes that's the target, and the target is not always the same. It depends on a lot of factors. I will say that if you start with a speaker that's got an even sound power, and you put it in a room in which the acoustical treatments are done so that the reverb time is the target and its smoother frequency, more often that target curve, the one that the Harman guys have been talking about for a while now, more often than not, that does yield good sound. But how often do you have that? I try to do that in the work we do, but I'm often calibrating in rooms that have have an acoustical package that wasn't engineered correctly, no acoustical package, speakers that have God knows what response, and that's the reality out there. That's how the world is, and entering and brute forcing one target curve for everybody is a recipe for disaster, I think.
Yeah, for
disaster
sure.
would be a big word. Is a recipe for not good sound. How's that?
Right.
Disaster would be running out of chocolate. That would
that would be a disaster. So some idea on package systems. Do you recommend, based on someone's asking about no, that's not the one I wanted. How much for a 6-speaker system? That really depends on the room size, the output capability requirements. Do you guys have a calculator on your website that says if you have a 3,000 cubic foot room, you need this series of speakers? I mean, is there some science to that?
You're egging me on to the next set of slides. I'll go through those as fast as I can. We have 5 packages that are based exactly on room size. The first 3 packages, Cinema 1, Cinema 2, Cinema 3, include all of the speakers, a completely custom engineered design, where we obsess over the design of the acoustics, the position of everything. We produce a 25-page plan set and all of the acoustical treatments and an on-site calibration. The acoustic design would be, like I said, about 20 or 25 pages of things that look like this. The acoustical treatments would be a bunch of absorbers, diffusers, bass traps, whatever it is that the design said you had to have. The systems are like these. Now, these prices are actually, I realized from when we started this 6 months ago or something, and they've changed. But as a general rule, if you had 1,000 square foot room, big room, so like 50 foot long, 40 foot long, we have a package for around $260,000 retail that includes everything you need to produce kick-ass sound. And what I mean by kick-ass is you can turn it up to 12. You can play movies and music at insanely high levels without any distortion. Everybody will be smiling all the way to the bank. It's fantastic. And it's all the speakers and the design and the treatment, the calibration, everything, all done white glove service. Does not include the installation. For the next size down of room, so a room somewhere around 600 square feet, so it'd be a 30-foot long room. We have a package for $144,000 that includes the design, the treatment, and calibrations. It's all of these speakers, our Rixos-Ls for the fronts, Rixos-Ms for the sides, etc. Everything you see here. Next size down, so this is always size related. So next size down, we have a package for around $94,000. That's all the speakers you need for a room around 450 square feet that will do full Atmos. So this is 3 front speakers, 2 wides, 2 sides, 2 backs, 4 tops. So this would be called a 9.4.4. So 4 subwoofers with a design, treatment, and calibration. It's all in. Then we have systems for smaller rooms, including Cinema 4, which is $68,000 for a 9.4.4, basically smaller speakers, smaller room. This is appropriate for a room around 300 square feet, so like a 20 to 22 foot long room. And then finally, for $42,000 in our speaker package, you get an 11 speaker system. So this is what I would call a 7.2.2. So that's what you need. So that's in our world. Granted, we make speakers in an artisan manner, all hand built in the office right behind over here in California, using very high-end componentry, one at a time. We carefully listen to them. We burn them in before we ship them. We listen to them. We obsess over them. We treat them with white gloves all the way through. That's what we do. It's high value. It's not cheap. But what you're going to get out of this is unbelievably good sound. So that's what we do. There are many other manufacturers out there with packages. I've noticed the idea of packages has grown more and more and more. A number of different people out there go, well, here's a speaker, but here's a package if you have a room about this size or about that size or about that size. As to prices, I'll be honest, there's people who make very good speakers for $600. They don't play very loud, but they're very well designed. They're mass produced somewhere in Asia, which I have nothing against that. But they're very well designed and they work well. And then there's speakers at $60,000 that are really badly designed. They just have really beautiful cabinetry, and they could be made anywhere. And price is not always an indicator of the sound, power, and frequency response you're going to get. Some of these charts I showed earlier are for some pretty expensive speakers. And so you can't always rely on that. And I know, Gene, you've seen some of those.
Oh, yeah, for sure. No, it's awesome. I mean, I really do think, it would be great if we could do this kind of stuff at, significantly lower prices too. I mean, I wish active speakers were more flooding the consumer market. They're just not. I mean, there's active speakers in the pro market, but generally speaking, most people are still using passive and they're using receivers and having all the amplification in there. And I hope to see this evolve and then trickle down. So maybe even have DIY options for people and, down the road. Because I just think
absolutely. You're right that in the recording studio, whether it's amateur project studio or professional studio, and in the pro audio business, active speakers are everywhere and they don't cost that much. I sometimes marvel at what some people sell as a 2-way, 6.5-inch 2-way for $350. It's insane.
Yeah.
I'll give a plug to JBL, who makes amazing speakers for around $800, 2-way active with a little bit of EQ in them. That's called mass production. It is not entering the collective unconscious in the residential side. You know, I guess I'll just start my own sedition over here, and I'll go, you know, all y'all who are interested in active speakers, go look at what's happening in the pro side. You know, there's many brands that make very good active speakers that you would plug the line output of your receivers and decoders right into, and you'd be amazed what you get. I will give a hats off to a company called Kef out of the UK that makes an amazing little two-way concentric speaker. I forget the model number out there.
LS50 maybe?
LS50, yeah. Amazing. Doesn't play very loud. You know, you look at a small speaker, there's just only so much SPL you can.
Well, it's like a near field. It's really a near field environment. That's what that's.
People in the recording side would call it a near field. I just call it a small speaker. It doesn't know whether it's near to you or not.
Right.
But you tie that with a decent pair of subwoofers from our friends at either SVS, JL Audio, whoever else makes good subwoofers for not too much money, and cross them over correctly, do a little bit of room EQ, either using the built-in EQ that's in some number of the receivers out there, manual, or hope that the automatics would rework. You'd be amazed what you get out of that.
Mm-hmm.
So you're right. I do look forward to more of this happening in the residential side. The whole idea of doing this in the active and digital side. I don't know if us as a company will gravitate down into the $500 a box speaker. It's currently not on our roadmap. Maybe it will be in the future. We'll see. But it is well worth it. So I do want to remind everybody who's watching that these prices for these speakers, these packages, include all the amplification, everything in it. Okay, so
and the acoustical treatments.
And the acoustical treatments for the larger packages.
Yeah.
So when you get down to an individual speaker, just so you know, our smaller speaker, the Rixos-S, is we're working on the price list because we've had a lot of bumps in price because of materials. But used to be $3,300. It may become $3,900 depending on what we can negotiate with our vendors. But that's a two-way, high quality. You saw the response curves with an amplifier. Okay, with a built-in amp that plays very loud for the size of the speaker because the amps are directly hooked up to the woofer and to the tweeter without a passive crossover in the middle that's dissipating a lot of power.
Cool.
So people often marvel at how loud these little things play for their size. Yeah.
Gotcha. Well, Anthony, Glenn, let me put Glenn's mic back on. Sorry, Glenn.
I wanted to point out one other thing is that the other cool unintended benefit of having all the EQ done in the amps / in the speakers is if sometime down the road you decide to upgrade your processor, you're not losing your room EQ. Right. So that's huge.
Yeah, because everything's already tuned in through the amplifiers.
And the corrections weren't done in the processor.
Right.
You can just swap out the decoder and you're done.
Yeah. Good point. Well, guys, appreciate you dropping some more knowledge on your products. Like I said, guys, I created a playlist for Grimani Systems if you want to go and watch all of the past videos we've done on these products. Anthony, I want to have you back really soon. I want to do, some more educational stuff on, the stuff we're talking about tuning your room to a house curve or to make a custom curve depending on the room. I also want to talk to you about, just different surround mixing and the fact that all of your speaker layouts are really Atmos layouts and not really Oro. I do want to talk more about why that is. I think, with all the installation experience you have, I think that's a very relevant topic to discuss in future live streams.
I would love to. That would be fun. We could easily spend a whole hour just talking about house curves and dialing that in, finding the right one, all of that. It's it would be fun. Let's do it. More chocolate and another hour.
Awesome. All right, guys. Well, appreciate you participating. Hey, guys, don't forget about our Patreon channel at patreon.com/Audioholics. We appreciate your support. You get direct access to us if you want to ask questions or suggest video topics. And I hope everybody has a good weekend. And until next time, my friends,